Hello everybody, today we are going to do modeling of general rigid body links using RBE tool. Okay, problem features, it's clearly use of RBE tool. And material properties, analyze type 3D structure, total Lagrange, boundary condition, it's you see, element type 3D shell element type 75. Yes, we gonna fix here and we gonna give load from here. Okay, at first let's do it the mesh basic manipulation nodes and 0 15 0, after that 19 15 and 1. Yes, and elements line, where is it? Here, line 2 elements 8 1 and 2. Okay, yeah, click this and we're gonna see now operation subdivide, division 3 1 1, elements 1 and click this. Okay, geometry mesh sweep nodes all exciting and okay, expand, we're gonna use expand operation, rotation angles, where is it? Yeah, 45 0 0, and repetition, where is it? Yeah, here 8, expand elements all exciting. Yeah, okay, we did this. Now subdivide, you can see subdivide, geometry operation sweep again, renumber, wait a second, at first we're gonna sweep nodes. Okay, now geometry mesh operation, renumber nodes all, click this, all elements all. Okay, but I think we're gonna make the mistakes. Let me sweep nodes all exciting. Okay, renumber nodes all elements all. I think we did this. Geometry basic manipulation, geometry mesh, sorry, nodes and 0 0 0 and 19 0 0. Yeah, okay, tables, let me do tables, where is it? Tables coordinates, tables name, one independent variable, type 19, time, type time. Okay, data points, where is it? Here, data points, add points 1 1 1 1, sorry, 0 0 1 1, wait a second, 1 1, yes, fit, and okay, we're gonna do one more, it's place type plastic strain. Where is it? Liquid plastic strain. Okay. Data points 8.15 and to 3000 feet. Yeah. Okay. Geometric properties. Where is it? Geometric properties, geometric proportion, name structure, shell, thickness 3. Okay. Elements odd, all, and okay. Material properties, Young model, standard 25,000 and Poisson ratio 0.03. Plasticity and yield stress 1 tables plus. Okay, elements odd, all exciting. Yeah, okay. Now transformation. Where is the transformation toolbox? Transformation cylinder obsolete. Syndic point 000 1900 to you can see and click this. I hope it's okay now. And going to links RB2, where is it? Here, new retained model section, retained node 4334 and twill and tights nodes and I hope it's okay now. The of draw of free, they choose the and okay, I think. Oh wait a second, what did I? Yeah, it's okay now. And let me boundary condition. New fixed displacement, name fixed displacement XIZ, rotation XAD, entities. Where is it? Here, nodes at 1, 5, 7, 6, 7, 8, 9, 10, 11. Oops, mistake. Okay, and click this. Yeah, okay. And boundary condition again, new structural, fixed displacement, name load. This is loading displacements X. We gonna use load only direction displacement X. Rotation Z, it's yes, rotation Z, table, time, entities, nodes 34 and click this. Yeah, it's only one from here. Okay, identify pilot section, arrow plus rings, solid, redraw, you can see now. Okay, anyway, from here and here. Anyway, it's not big deal. And load case and job promise. Let me do load case. new static concurrence. Where is it? Yeah, concurrence testings method residence and displacements include moments, relative force tolerance 0.05, and this one, displacements include rotation, this one, and this one. Stepping procedure, where is it? Wait a second. Stepping procedure, yeah, here. Steps, it's 10 times. Do it. Okay, save and drop element type, new element types. Shell membrane, where is it? Here. Which one? 19. And choose all exciting. Okay, jobs, new structural analyze, available, name linear, available, load case, run, wait a second, run, submit, and you see there is no mistakes. Maybe open binary first, but wait a second. Okay, and jobs, let me do one more structure. This one no linear, available load gate 1, analyze options, large strain, it's already this version, there is no large strain. From here you can see, and advanced options, load strain, total load range. Okay, run, submit 1, and okay. Now resultant discussion, where is this? Okay, let me see discussion. Okay, this is the first one, load case. Which one? The deformed shape of cylinder without width, total range, figure 3 and 4 respectively. From these figures is clearly seen difference of ovalization cylinder where the rotation result total range shows over. Okay, let me show this. Note 21 and 23, lowercase at first, run, open binary post. Let me show this. Oh, I hope it's okay now. Anyway, displacement, counterband, displacement Z. Okay, it's wrong, I think. And where is this? Deformant and original. Why we gonna make a mistakes? Input files, displacement here. We choose, I think, wrong. Let me show jobs units, not this one. Wait a second. Oh yeah, it's working now. I made a mistake, sorry. I hope it's, yeah, this linear analyze, and I think, where is it, which one, this list, wait a second. Anyway, let me explain. This one, the first one, I did this, wait a second, yeah, linear analyze of this, and you can see if we start from beginning, and when you look at this, oh wait a second, not to maximum, sorry, v working displacement d, let me fix it. Open, where is the open binary post, jobs, load k results, multiply, not displacement, we gonna work displacement z, okay, and work. Yeah, you can see displacement z, load case 1, and this one load case 1, and this one also. Anyway, the main point you can understand, we use RB2. What is the RB2? Let me explain. RB2 link is defined along one edge of the cylinder. First R reference node, and second is Z local coordinate. It's simple actually. Today we saw RB2 operation. Comment, what do you say? Yeah, and thanks for watching. This is video of 10. This is a number of 10 videos. I hope I will upload new videos, because right now I am unemployment. I'm looking my career opportunity. Anyway, if you like it, just subscribe me and like video. Thanks.